Hi, my name is Emily. In this video, I'm going to talk about the different types of solids that we learned about in Chapter 5. Solids get their name from their secure structures consisting of strong intermolecular forces that lock molecules in place. Solids can be characterized by the arrangement of their particles, or lack thereof. There are two main categories of solids. The first is crystalline. Crystalline solids have specifically ordered particles. The second is amorphous solids. Amorphous solids do not possess the regular repeating patterns that we see in crystalline solids. Crystalline solids exist in many forms due to the different forces that occur within each. There are four types of crystalline solids. They are ionic, molecular, covalent network, and metallic. The first type of crystalline solid that we're going to talk about is the ionic crystalline solid. Ionic crystalline solids are held together by ionic bonds. Ionic bonds are chemical bonds that occur when valence electrons are shared between a metal cation and a non-metal anion. An example of an ionic crystalline solid is sodium chloride, or table salt. Sodium metal has 1 valence electron, while chlorine has 7 valence electrons. The two atoms bond and share their electrons, ultimately forming an ionic compound. The next type of crystalline solid is called molecular crystalline. Molecular crystalline solids consist of molecules that are held together by non-covalent interactions called intermolecular forces, which I abbreviate IMF. An example of a molecular crystalline solid is ice. Ice contains the following intermolecular forces. Hydrogen bonds exist between the hydrogen and oxygen atoms. Because water is polar, dipole-dipole attraction also occurs. This type of attraction exists between polar molecules. London dispersion forces, also known as induced dipole attraction, also occurs in ice. The next type of crystalline solid is the covalent network crystalline. A covalent network crystalline solid is a solid that contains covalent bonds between its atoms. Few substances exist as this type of solid. A couple examples are diamond and silicon dioxide, more commonly known as sand found at the beach. Diamond consists of only carbon atoms. Each carbon atom is bonded to 4 other carbon atoms. Sand consists of covalent bonds between silicon and oxygen atoms that extends throughout the solid. Our final type of crystalline solid is called the metallic crystalline. Metallic crystalline solids involve metal atoms and free electrons that form metallic bonds. Metallic substances are solid at room temperature. The only exception to this rule is mercury, which is liquid at room temperature. Metallic substances contain a specific set of properties that are exclusive to other types of solids. They are malleable, meaning that they can be reshaped through physical force, like hammering. They are ductile and are used to produce thin wire. Finally, they are good conductors of electricity. Contrary to crystalline solids, amorphous solids have no specific shape or structure. Amorphous solids consist of molecules, atoms, or ions that are bonded to one another either covalently or non-covalently. Examples of amorphous solids include glass, rubber, and plastic.